Okay. So my name is Jamie McCutcheon. I am, sorry, trying to get a couple of things cleaned up. I am the principal founder of Rymar Waterworks. Appreciate you joining today. We're going to do a webinar based on for Skimmer Basin Design. We're going to have a focus today on North Carolina, Ohio, and Texas. Looking at those that had signed up, I think that's seem to be several from those areas, but we'll cover other states as well. Just real quickly about me, I'm a 1992 graduate of Clemson University in civil engineering. Founded CCAD Engineering in 1999. We did primarily land development, site planning, a lot of stormwater related stuff. Invented the Marley float skimmer in 2013. And I'm a licensed professional engineer in South Carolina, North Carolina, and Georgia. So I'm no longer active. I sold CCAD Engineering about 7 years ago. So now we're really focused on more of the skimmer and do a little bit of development consulting, but mainly focused on the skimmer business. I'm going to shut my video off now just because it helps with the recording. But also, if you do have any questions today, please use the chat button. I have a couple of people helping me monitor that on here as well, but you can use the chat feature if you do have a question as we go, or feel free to unmute yourself and ask. So, all right. So today, what we're going to go over is we're going to do an introduction to skimmers or floating outlets. I know there's a couple of states now that have just recently started adopting or I guess enforcing skimmers. Texas is one of those. Virginia is another, and a little bit in Indiana. So if you're not familiar with just the basics, we're going to go cover that. We're going to talk about how to do skimmer basin design. We're going to run through the specific requirements of North Carolina, Ohio, and Texas, but we're going to, the general stuff here will apply to most states. Then we're going to do a little pivot, and we're going to talk about using skimmers for post-construction and why you might want to do that. If you do, we're going to help you know how to model it in HydroFlow, which seems to be the most common hydrology program. And then we're going to wrap up today talking about our new water quality filter and a filtration-based design and why you might want to consider that in your design. So before we get going in, just want to know, how familiar are you with skimmers? So I'm going to launch a little poll here, and this will just kind of tell me with our group we have today, how much familiarity you have with skimmers in general. All right, so looks like most people here are in the somewhat, so about 70% are in the somewhat. One is pretty new, and then about 26% have used them on several projects. So hopefully we're going to have something that everybody can learn something today. It's going to be a very technical presentation, but that's good for me to know. All right, so what we used to do before skimmers is we had a perforated riser, typically had either perforations throughout the riser or sometimes just a hole at the bottom. But it was mainly discharging water from the bottom of the sediment basin, which is where we're trying to get all the sediment to settle to. And kind of the purpose of a sediment basin is to capture that sediment by settling. So skimmers have been around now probably about 25 years. Some states, again, more than others. And what they do is they meet the surface withdrawal requirement or surface dewatering requirement that's in most CGPs. So what they do is they drain the basin from the top down, generally over a 2 to 5 day period. Gives time for the mud to settle, and it releases that water from near the surface of the pond where the water is cleaner, so that if you look at the water column, right at the very top, you may have more floating debris and a little more trash to deal with, but just below that is going to be cleaner. And then, the idea here is we're trying to get sediment to settle to the bottom. So, as you go to the bottom of the pond, it's going to get a little dirtier water. So there are a number of skimmers on the market. The Faircloth skimmer was the first one out about 25 years ago or so. You got the erosion supply skimmer, the IAS skimmer, and the Marley float. So there are different varieties out there. There may be a few others out there that I'm not as familiar with, but these are the ones that we've kind of seen most often. So this is a little quick video of a skimmer in a sediment basin. So this was a basin that was Had about an 8-acre site draining to it. And what I'd like to show here is that's the outflow from that basin. So, that surface withdrawal is releasing fairly clean water. That's pretty low turbidity. I don't know what the NTU requirements are there. We're not required to test in South Carolina, but that is actually pretty clean water considering what that basin looked like. This specific site was about 100 yards from a lake, and so it was very important that we not turn the lake, turbid to there and capture as much sediment as we could on site. So there are three basic fundamentals when it comes to sediment basin design. So number one is basin volume. So the basin volume is based on the area flowing to the basin, and this does vary from state to state as far as what their standards are. So what we see in most areas is either 1,800 or 3,600 cubic feet per acre flowing to the basin. So if we had an example, say 5 acres at 3,600 cubic feet, that would be an 18,000 cubic foot required volume for your dewatering volume. Now, some areas, Ohio, Indiana, and Texas are among them, also require basins to have a permanent pool or sediment storage, and that area is not drained by the skimmer. And so you do not include that volume when you're sizing your skimmer. Fundamental number two is dewatering time. So sediment basins work by allowing time for sediment to settle to the bottom. So, depending on what type of soil you have, may vary how much time you think it should take. The general standard that we see in most states is 2 to 5 days. Again, that does vary. You'll see some variation when we look at these, but generally the target is 3 days. That's kind of become a typical standard, although not everywhere. But do note that your engineering judgments need to balance the need for extended times for certain soil types versus the frequency of rain events. So we're based in South Carolina, so that, every afternoon thunderstorm that we get, we don't want to have the basin take too long because then it won't have the volume for the next storm that comes through typically the next day. And then the third fundamental is simply flow rate. So once the basin volume and dewatering time are established, then the required flow rate's easy to determine. It's just the volume divided by dewatering time. It's going to give you the flow rate. Now, typically you're going to have a range of flow rate here. So in our case, if we assume we had a 2 to 5 day range, then you could have anywhere from a 9,000 cubic feet per day flow to a 3,600 cubic feet per day flow. It is note that a lower flow rate will often result in a smaller, typically less expensive skimmer. And so just something to keep in mind when you're determining which skimmer to select there. Now, one thing about this, and this is a detail from a set of plans that a distributor sent us, and just want to point out the need for basing it on required storage versus provided storage. And so in this case, the engineer had this, pond information, and they had spec'd the Marley float, which we appreciate. They had given a time to drain of 72 hours, and they had specified an 8-inch skimmer. Now they had here sediment storage required and provided. This was actually the dewatering volume, not sediment storage, but the required was 1,754 cubic yards, and the provided was 7,500 cubic yards. So based on the required storage of 1,754 cubic yards, they would have used a 3-inch skimmer with a 2.5-inch orifice, and the cost of that, at least for ours, retail cost is about $1,100. Based on the 7,478 cubic yards, which is what was provided, they needed an 8-inch skimmer. Actually, with 8-inch with a 6.5-inch orifice is what we probably would have gone with. Would achieved about a 2-day drain time. That was, the retail price on that is $58.99. So you've got a significant price difference between these two. And the other big thing here is that 8-inch skimmer is going to drain that required volume in less than 9 hours. So in most cases, what you're looking at is a minimum drain time for the minimum required volume of typically 2 days is kind of the general standard. And so in this case, because they put in this much larger skimmer than they needed, not only was it more expensive, but they did not meet their requirements to drain that volume in, say, 48 hours. They actually drained it in less than 9, so drained it much too quick. All right, so one more poll here. I'd just like to know where you're located today. So I know we've got a pretty good crowd, about close to 50 people on. So just curious if you can tell me where you're dialing in from. All right, and so most people have done, so we're going to end that and take a look. So it looks like bulk of people today are South Carolina, Ohio, Indiana, one from Texas, and 10 others. So other wins today. So good. I appreciate everybody joining us from across the country. All right. So I think we had a few in there from North Carolina. So we'll talk about North Carolina sediment basin standards. Um, North Carolina is one of the, really is the state that originated skimmers. The Faircloth skimmer was kind of the first one out there and is based in North Carolina. So they started this requirement for surface outlets. So, sediment basins and traps that receive runoff from drainage in North Carolina, it's 1 acre or more. That's a little smaller than most areas. Withdraw water from the surface, um, unless this is infeasible. And what they say is in most cases, it's rare to be infeasible. The only exception to that is maybe if you're in an area that has a lot of freezing. So North Carolina standards, 1,800 cubic feet per acre of disturbed area. Um, and they have a dewatering time minimum of 48 hours. Now this again, they call it minimum sediment storage volume, but in North Carolina, it's a dry basin, so that volume is the required dewatering volume. And again, dewater from the surface. And then here they specify with a skimmer, the basin should drain in 2 to 5 days. North Carolina also provides some details, has some similar information there. They also have a minimum surface area requirement. And then this is their skimmer sediment basin detail. Again, in their manual, they say any skimmer design that dewaters from the surface at a controlled rate is acceptable. So what we typically do is make sure that you've got design calcs, or what that flow rate is for that skimmer. But if a contractor wants to build their own, as long as they can verify what that flow is, then that works too. All right, in Texas, so Texas has just recently started enforcing requirements for skimmers. Um, and what they say is that you must provide sufficient storage to contain a volume of a 2-year, 24-hour storm from each disturbed acre drained. Or if you don't do that, you've got to have at least 3,600 cubic feet of storage per acre drained. They also say, now to utilize outlet structures that withdraw water from the surface. They give you the North Carolina, or excuse me, North Central Texas has a manual, gives key considerations on how you design the sediment basin. They've not updated their detail yet to include a skimmer. They also say the minimum design dewater time is 36 hours, and they want to drain it in less than 72. So that's a little different than the 2 to 5 days. Basically, you got 1.5 to 3 day time frame. And your primary outlet is going to handle the 25-year storm. Again, withdraw water from the surface. And they also note that discharge rate for skimmers are dependent on the orifice configuration in the skimmer, and to use the manufacturer's flow charts to select the skimmer based on the flow rate. So it is important to note different skimmers do flow differently. We'll talk about that in a minute, but just make sure you've used the manufacturer's recommendations when you're sizing them. Again, they have a little design form, gives you that same information, minimum required area, that 3,600 cubic feet, excuse me, or the 2-year, 24-hour storm. And again, just the rest of your design information here. So then also we'll jump into Ohio sediment basin standards. We have a good group from Ohio today. Ohio has a requirement for sediment storage below the skimmer of 1,000 cubic feet per acre. They have a minimum dewatering volume of 1,800 cubic feet per acre. It is important to note they have a larger minimum dewatering volume in certain areas in their Big Darby Creek watershed. So that's an impaired watershed, I believe. And their detention time is 2 to 7 days. Ohio EPA has a sediment basin volume or sediment basin design tool on their website. It lists, you list your total drainage area and your disturbed area. The total drainage area is what your dewatering volume is based on. the disturbed drainage area is what that additional sediment storage is based on. When you put in your basin here, you've got your sediment storage zone and your dewatering zone. Make sure that your volume calculations meet the requirements there. It is point out the tool that they have has multiple skimmers available. They specifically do include the Marley float as one of theirs. You just manually plug in the orifice size selected and dewatering drawdown time when you're doing this for Ohio. And so just a little quick comparison of these three states. North Carolina, again, for basin volumes, 1,800 cubic feet per disturbed acre. Texas is the 2-year storm, or 3,600 cubic feet per acre. And Ohio is 1,800 cubic feet per acre for total acre, plus an additional 1,000 cubic feet per acre for disturbed sediment storage. Again, that is not included in your dewatering zone. Some states have surface area requirements, or length to width ratios, or maybe a max depth. Principal spillway, that's typically the skimmer and the riser structure, needs to handle either 2-year to 10-year storm, and emergency spillway would handle the 10-year, 25-year storm. Where skimmers are required, again, North Carolina goes down to as small as 1 acre. Other areas are basically 10 plus acres. What we generally see in practice is if it's got a riser structure included, then they want to use a skimmer. If it's a sediment trap with like a stone rock outlet or something like that, obviously you wouldn't use a skimmer then. And then dewatering time, again, 2 to 5 days, 1.5 to 3 days, or 2 to 7 days. So main thing here is, a lot of consultants work in many states. And a lot of times, as engineers, we kind of get a standard that we're used to working with. It's really important to make sure you know the specific standards for the states you're in, because they do vary quite a bit, especially when it comes to sediment basin design. So we talked about flow rate a lot, and this chart really is going to highlight why that's so important. So this actually came from a study that Georgia commissioned to have done, and TRI Environmental did this for them. So I'm going to focus here on the right side, these 3 columns. So there's 3 different 3-inch skimmers. So TRI has a test tank for skimmers that's 4 feet deep. So down at a 1 foot depth, 2 of the skimmers were pretty close in flow rate at about 37 GPM, but one was nearly double at 70 GPM. All 3 of the skimmers had an increase in flow from 1 foot to 4 feet of about a 25% increase in flow rate. So a lot of times engineers feel like skimmers are constant head, constant flow devices. Testing has shown that's not actually true. There is a flow rate curve to pretty much all skimmers. And again, at the 4 foot depth, 2 of them were close to 50 GPM, and one again is nearly double at 90 GPM. So as the engineer consultant, if you just specified a generic 3-inch skimmer and didn't give any other information for that, the contractor may buy one that flows slower or faster than you intended. So really important to identify the volume of the basin and the time frame, dewatering time frame, to determine what that flow rate should be. So to help with that, we have a design tool. These are all available on our website for free. This is a site, we just assume one in Charlotte here. So one thing about the design tool, and we developed this in conjunction with many MS4s and state agencies. What they found is that the biggest mistake the engineers make when they're sizing the skimmer and doing this design is they use the provided volume of the basin, which in some cases may be much larger than required. And so we built in this check here. So this is your required dewatering volume, the area to the basin, and then the cubic feet per acre. So you can edit those as needed. And so in this case, we came up with a required volume of 13,500 cubic feet. So over here in the tool, we are now going to set the minimum and maximum time to drain. So you got here 48 to 120 hours, or 2 to 5 days. The pond depth. Now the pond depth is very important. You're not going to use your total pond depth necessarily. You're just going to use the pond depth required to achieve the required dewatering volume. So if you've got a pond that's going to be, say, your detention basin post-construction, that pond may be 8, 10 feet deep or more. You don't want to plug that in here. You only want to use the depth that's going to equate to reaching that required volume. Then you can put in your top length and width and your bottom length and width. Now we recognize that there's very few square or rectangular basins, so use your engineering judgment in that and get this, to a reasonable number. We try to get this calculated pond volume to within about 5% of the required dewatering volume. Again, you're trying to hit a 3-day range here, so we don't have to spend time to get it to the exact, but we want to get it within 5% or less. And then this tool will use the flow rate curves for all of our skimmers with each orifice configuration based on third-party testing to calculate that. Now, we made it simple. You come down here to the bottom of the tool, there's a skimmer report page tab. Go to that tab, there'll be a nice, neat 8.5 by 11 that you can print out and put in your SWIP or directly on your plans. The top of this is going to have that check, so it makes it very easy for the reviewer to see that, yes, my required pond volume and my calculated pond volume are pretty close together. We're going to calculate your minimum flow rate for that maximum time, the maximum flow rate for the minimum time. And so all that'll be here as long as all the other information you entered on the spreadsheet. And then because it's our tool, we're going to tell you the drawdown time for every one of our skimmers. And then based on the time frame that you set, which ones meet that criteria. So which skimmers, meet the 48 to 120 hour time frame. And then as engineer, you're going to select the one that you want. So in this case, we typically shoot for that 72-hour, 3-day time frame. So I would probably go with our 2-inch with a 2-inch orifice. One is going to hit that time frame. Two is going to be the least expensive of the skimmer options. However, let's say you're near an airport or you just need to get that water out as fast as possible, you could go down to our 4-inch with a 2-inch orifice and drain it in 48 hours. So, it's up to the engineer which one to pick, but you've got that range to pick from based on the state requirements. We also have some basin details available. So we have 4 different details. So this one is without a riser structure. So it's just a pipe through the dam. This would typically be a temporary basin. And this is a dry basin here. We also have them with a riser structure, which is probably more common. This version of that has a permanent pool. So all these are going to have a sediment basin design criteria chart. So here you're going to set the criteria for all the basins on the site. So if you have a minimum or maximum length to width ratio, what is that sediment storage required? What's that dewatering volume required? If it's a dry pond, you won't have the sediment storage there. What's the surface area required? If there's a formula or other method they use. Here's where you're going to set your minimum and maximum times for dewatering. So you got 48 to 120 hours. Then you're going to have, all your basin specific information. So here's where you're going to show that your required sediment storage meets your provided, or your provided meets your required. Same thing on your dewatering volume, your drainage area, disturbed area, flow rate, so on, and all your basin information here. So then you're going to get over here to the skimmer information. So you're going to have your skimmer size, the skimmer orifice diameter. Most skimmers have like a skimmer size and then a way to reduce the orifice. So we have that here. It is our tool, so we plugged in Marley for you, but this is editable as well. Is an equal allowed, yes or no? Most of the time that is yes. There may be rare occasions where that is a no, but so the contractors need to know if they're allowed to provide an equal or not. And then what's that skimmer flow rate, the minimum and maximum? Again, our tool has calculated that for you. So if you put that in here, then it's really easy for the contractor. If they say, hey, can I use this other skimmer? Well, does it meet that requirement or not? If it does, then you're good to go. If it doesn't, then it doesn't meet that. So the idea here is that you get all that approved on the front end during your review, because obviously sediment basins are one of the first things to happen on a construction site. And, contractor calls you up and they're out on site and they said, hey, I want to use this other skimmer. Well, you don't have time to go through another review or go back through a review process with most MS4s. So you need to know, does it fit that or not? And be a simple shop drawing type review for that. This is our detail for our skimmers. A couple of things quickly to point out about it. I know you can't read this chart, but that is the flow rate for each skimmer with each orifice configuration from 0 to 4 feet deep. All of our skimmers have an orifice plate. And so we have standard orifice sizes that come with each skimmer. Some other skimmer models allow you to cut up a little disc that allows for kind of more variations. But we didn't do that. We just kind of went, because most times you've got a range of time to hit. So we just went with standard sizes. So it'd make it a little easier for the contractor to do that. And we'll show a little video later about how that works. The biggest question we get asked is, how long does this pipe need to be connecting the riser structure to the skimmer? Most manufacturers, including us, recommend about 1.4 times the height of the riser. This allows the skimmer to come up at about a 45-degree angle, when the pond's full. And so that works well, works for most skimmers. And so that's kind of a good rule of thumb. We typically recommend a minimum of say 8 feet, maybe go down as little as 6, depending on the size of your basin. But let's say this riser structure was only 2 feet tall. I really wouldn't want to put just a 3 foot stick of pipe here. I'd like it to be, floating out a little bit further away, even though technically it would rise to a 45-degree at that height. You want to give it a little more room to work there. We also specify this 12-inch depression here. This would obviously be for a dry pond. If you're in a state that requires a wet volume, you're going to have more than that. And we've got a picture in a minute to show you why we recommend that. One of the things we have is we have a skimmer calculator tool on our website. Now this tool is a little bit more simplified than our Excel tool. It's just hard to put everything on the website that the Excel tool has. So this one, you have your basin name, your required volume, you set your range of time. That 2 to 5 days is typical, but that's editable. It'll calculate your minimum and maximum peak flow for you. And then it will give you the skimmer size and orifice and approximate drawdown time, for whichever ones meet within that range. Now, one thing to point out here, and this question just came up recently, this flow rate is based on our peak flow rate at 4 foot depth. And so that drain time is probably going to be a little bit faster than actual drain time. So, because the flow rate does slow down as the pond depth decreases, it may be, the actual drain time may be like 2.3 or 2.4 days. We did this on purpose. Typically, you want to be a little more conservative, and typically a slightly longer drain time is better than a slightly faster drain time, because if you're trying to meet that 2-day minimum, if it goes to 2.3 or 2.5, that just gives a little more time for mud to settle. So if the most accurate way to do it is our tool, but this online tool is just a simplified way. And the advantage of this is once you do that, you hit download, it will create a nice custom detail for you that'll put all that information in for your skimmer detail. So just new tool that we have, gotten pretty good feedback from engineers so far on this, but just want to let you know that's available. So here's a picture of a freshly installed basin. So you can see they tracked in the sides, they got their baffle in, they just trenched it in, that's good. The skimmer's sitting here. This goes back to why we have a depression specified. So what the contractor did is they graded the basin, then they came in and put a stone pad in. And so what happened is they raised that skimmer about 6 or 8 inches off the bottom of the pond. And you can see here, the pond's holding a little bit of water. Looks like a lot of it is either evaporated or infiltrated. But if you want to get this pond dry as quickly as possible, you really want the skimmer sitting down, and so that any water that accumulates right around the skimmer to drain it as much as possible. So that's why we have that 12-inch depression on our detail, so that the skimmer sits down and drains if it's a dry pond, helps to drain it completely, minimize any issues with mosquitoes or just ability to get grass established and other things. So this is probably the worst install we've ever seen. Unfortunately, it was our skimmer, but I believe this came from an inspector in Ohio. Now, I'm not sure even how they attached the pipe to the opening there. It's only about 6 inches, so it's definitely not floating up any. They've got this valve open anyway, so I don't know that the skimmer's really getting any water through it. But anyway, sometimes things are not installed correctly. This one obviously is not installed correctly, is upside down, which is surprising because there's a sticker on the top of the skimmer that says this side up, and actually has a QR code to an installation video. But they put such a small pipe here, it's not going to float very far. So this pond's still going to drain down, probably drain too fast, and it's going to discharge from the bottom, but hopefully that got corrected pretty quickly. Other thing to point out is skimmers are not maintenance free. They do require some maintenance. So when you see vegetation growing in the skimmer, it's time to do some maintenance on it. So this was a different brand of skimmer, actually had a big root ball inside of it, which is why this pond wouldn't ever drain out. So looks like we may have a couple of chat questions before we go into. Someone asked about the web address for the Ohio EPA Sediment Basin Design Tool. Dale, I don't have that handy right now, but if you'll shoot me an email, I will get that to you shortly. So that wraps up our sediment basin design. Before we go into the permanent use, anybody got any other questions on sediment basin design? All right, while we're waiting on that, I've got one more poll for you. I want to know, have you ever considered using a skimmer permanently? And so if you would, we've got about 50 people, they could answer that. I expect most will be no. I've got a few yeses. That's great. Every time we do this, we seem to get a few more yeses. So give it one more minute here. All right, we got majority of people have answered. So majorities no, that's typical. That's typically what we see, and that's real reason why we include this. And so we're glad to have you on here today. We have about 3 that said yes, they considered it, or they considered it, and then we got 5 that said yes, they've done it. So that's awesome. Glad to hear that, and hopefully it's working well. All right, so let's go in to talk why you would do this. All right, so first let's talk about our typical dry detention basin. So that's the most common stormwater BMP typically across the country. I recognize if you're in a coastal area, high groundwater table, a wet pond may be, but in most cases it's dry. And so what happens at end of construction is the skimmer's removed. You put a low flow orifice installed at the bottom of the riser, and if you're doing water quality and doing the traditional first flush method, you're releasing that first flush over 24 to 48 hours. So you got a small orifice down there to do that. And because of that, you're going to have to do some sort of guard to keep that from clogging up. Because again, what we're trying to do is we're trying to create ponding and get sediment to settle to the bottom, but then we're discharging from where that sediment concentration is the highest. So, we all understand how sediment works. The big stuff falls out quicker, the small stuff takes longer. If you've got a pond situation, you've got that suspended sediment, and as you go from inlet to outlet, it's going to tend to drop out, and you're going to have the cleaner water on the surface, which is why we do the discharge from the surface for sediment basins. And so again, basins rely upon that natural settling of the sediment particles as they travel from the inlet to the outlet. Your skimmers release that cleaner water from the surface. They have become widely accepted for construction, and they've been proven to be very cost effective. So doesn't it make sense to maybe consider using that same method for post-construction, especially when it comes to water quality and trying to achieve our TSS requirements? So we've got a little case study here. So we did a retrofit of a pond. And so this pond used to have a 2-inch outlet in it. Actually, the 2-inch outlet was buried. It's about 6 feet below what is now the bottom of this basin. We, the pond, rather than cleaning out the pond, we ended up redesigning the pond. It was a rare pond that actually had excess volume in it, so we were able to do that. But we put in a 5-inch skimmer. Again, we had a 2-inch orifice that was there before. And so this was a pilot project with the county because they never used a skimmer permanently before. And so we were monitoring this thing and making sure and it was working well. Well, about a year later, the landscapers cut the pond and let all the debris kind of go to the bottom of the pond. And before they could get it out, they had about a 5-inch rain that day, and it washed all the debris down to the basin. Well, here's the skimmer sitting there. So, the skimmer was able to drain the pond even with that amount of debris. It's hard to tell in this picture, but that riser structure is about 12 feet tall. These are about 6-foot riser sections. And so if that was a 2-inch orifice and it had clogged up and the water was stuck at this level with these other orifices, that's about 8 or 9 feet deep. So getting to that 2-inch orifice to unclog it would be extremely difficult and probably dangerous. So if nothing else, then for maintenance and just keeping that low flow outlet working, skimmers are worth considering using permanently. And you're going to get some enhanced water quality because you're doing that surface withdrawal. So if you're going to consider doing that, we got to know how we plug that into HydroFlow or whatever program you're using and modeling that. So to run through a little quick HydroFlow example. So this is an actual site. It was done in the city of Greenville, South Carolina. And the city has a unique requirement. They require quantity control during construction. So this was actually was a sediment basin, but we had to design it not just for sediment control, but for quantity control as well. And so they had about 5.5 acres. It was about 2.25 acres going to this little small basin. About 3.4 acres was undisturbed. And so pre-development, we're looking at an area of 5.5 acres, curve number 59, time of concentration about 18.5 minutes. Post-development, the undisturbed area was about the same. The disturbed area, again, 2.23 acres, CN of 86 for disturbed earth condition, time of concentration about 7 minutes. So when you're building your basin in hydroflow, it's important to create a stage for you to be able to enter that skimmer flow later. So in this case, that my basin has a 0, 0.1, 0.3, 0.5, and a half a foot up to 4 feet. Just so happened this basin happened to be 4 feet deep, or just under 4 feet deep. So the skimmer, again, has the flow rates on here. So, you've got the flow rate at 0.1, 0.3, and then every half a foot up to 4 feet. And so when you're building in your outlet structure, you're going to build your barrel first. Okay, this is your pipe going out of your basin. So in this case, we had an 18-inch barrel sitting in elevation about 958. They had an additional orifice in the riser structure, a 6-inch orifice going through the riser. And here was our riser, and our riser had a rectangular weir at the top of it. Now, how we put in our skimmer flow was this user-defined column. So simply enter the user-defined flow off of the detail at each stage per the detail. So you build that in, and that will build in your flow rate curve into your model so that it will model it correctly. And Laura saw that in chat. Appreciate you providing that information on the Ohio EPA. So what you do then is, what happens if you're over 4 foot depth? Okay, this pond that we're looking at just happened to be 4 feet deep. So there's a couple of different ways to do that. So you can either just maintain that flow rate at the 4 foot depth, because the flow rate curves, I didn't show those, but they generally flatten out around 4 feet. You can extrapolate using the last 3 data points. Or let's say your pond's really deep. Say you got an 8 foot deep pond. You're like, well, I don't want to just extrapolate that for double what I've got data on. Well, we've got the flow rate curves built in our design tool we talked about earlier, and it breaks that depth into 20 different increments here. And so what you do is just put in your total pond depth here, and then it'll give you that. And then you can then compare that to the flow rate for each one of the skimmers with each orifice configuration. So whichever skimmer and orifice you think is going to work for your pond, you can now plug that in. And what you can do is, find some of these that are closest to their nearest foot or half a foot or so, and plug that in for you. In this case, you see very little, almost no flow rate change, because this is our 2-inch skimmer with a 1/2-inch orifice, so it's flowing at a trickle anyway. But as you look at larger skimmers, you're going to see much more of a change across that depth. So you plug that in, and then this is going to be your schematic of your riser structure for in hydroflow. So normally you would have a low flow orifice here at the bottom. In this case, you do not. You've got, because that's your user defined flow instead, you've got your 6-inch orifice, your weir, and your riser. But if you look at your stage discharge curve, this is your skimmer flow here. So it's factored in, and then your other orifices kick in at each point to see that going up. So hopefully that makes sense on modeling and hydroflow. We do have on our website, we'll talk about it at the end here, some training modules that go into a little more depth to that. They're like 10 to 15 minutes long, but that's kind of the basics of how you would model. So we're going to wrap up here. Got about 20 minutes left. We're going to talk about our newest product and why we want to do it. So this is going to be about advanced skimmer modeling for filtration-based water quality. And so why would we want to do that? Okay. Well, what we've come out with is a product that adds a filter around the skimmer. So you've got an outer filter that's a screen, it's polyethylene fabric. Got an inner filter that's a non-woven called Absorbit. Advantage of it actually absorbs hydrocarbons as well, has some benefit for metals. And then those 2 filters screen stuff going to the skimmer. So the idea is the skimmer's pulling water through these filters, and then those are taking out the pollutants, and then it gets to the skimmer to get discharged. The filters are about 3 feet deep, and so what we're doing is we're allowing gravity to do its work there. So you still got Stokes' law, so you still got sediment or settling, and so the idea is that if it settles down to 3 feet, there's not enough turbulent force to pull that particle back up to the skimmer to be discharged. So this is a kind of combination hydrodynamic, settling feature versus filtration feature. So go back to that pond we looked at briefly. So we used that pond for our prototype. So we've got, this was our I don't know, maybe our sixth or seventh different prototype we used. And we finally found one that seemed to work. That's the two-stage system. You can see this outside was actually a turbidity curtain that we had made with the filtration fabric in the middle so flow could come through it, not just under it. And then this is our non-woven. You can see here, there's some slits in it. So this is actually two layers of non-woven. And we have panels that are 6 inches wide, and the two panels are offset 3 inches. So the idea is that water either flows through the filter or weaves through the filter and creates contact time on those panels to help them kind of grab on to the sediment particles and other pollutants attached to the sediment. So this has been in that basin for over 2 years. And we really felt like it was doing well. So we had a time-lapse camera out there monitoring it. We'd always go out there after each big rain and check it out. But you can see here the turbidity in the water outside the filter is much higher than the turbidity here around the skimmer. And this picture is actually the outfall of the pond. So, pretty clean water considering what's in it. Definitely wouldn't drink it, but for what we're trying to accomplish here, take out the sediment, it's doing a good job. And so we decided at that point to have this model tested, and we got over 90% TSS removal when we did our testing. Now, important to talk about what we tested, how we tested, and what that was based on. So TRI Environmental, again, the company that did the work for Georgia, they're actually based in Greenville as well. So convenient for us, but highly reputable company. Did testing in accordance with an ASTM standard. So ASTM hasn't had sediment standards or stormwater standards out long, but a few years now. So they've got a standard called C1746, and that establishes your soil gradation, your flow rates, all the technical stuff that needs to be done so that you can test products on an apples to apples basis. So what we did, because we're testing a product that goes in a pond, and ponds have other features. Ponds have forebays, they have travel distance, they have vegetation, they may have a aquatic shelf, or variety of things that are going to help with TSS removal, help with water quality. It would be very difficult to know what percentage we got from those versus what percentage we got from just this system of filter and skimmer. So we took all that out. And so in a test tank, we're introducing the sediment laden water here within about 1.5 to 2 feet of the first filter. So it's basically entering straight through the filter or below the filter, through the other filter, and then discharged by the skimmer to go out. We modeled this as a dry pond, so it started off dry, raised up, had a time frame, and then drained back down. And when we did that, we got 92% one test and 96% the other test. So we've now installed an updated version of the product in that same pond. So here's a good picture of that basin. One thing to know about this basin, and this upper picture kind of shows it, it's about a 40-acre watershed, and it has almost no other stormwater management in the watershed. And so this pond gets all kinds of junk and debris, which is probably why that 2-inch outlet got clogged up and had so much built up in here. But we've got a time-lapse camera here. We're monitoring this. We're keeping a close eye on it. So speaking of that, this is a short time-lapse video. You can see here, there's a lot of debris around the outlet structure. Actually, beavers have gotten in this pond and have tried to dam it up. But the skimmer's still working, even though the beavers have built up a dam around it. So we've got to get the owners to go out and maintain that. But here's just a good little quick time-lapse video over a couple of days. Had a pretty big rain event, filled that pond up. The skimmer's draining it down, although we're getting a little more rain. Unfortunately, a lot of this was at night, so it's a little harder to see, but you can kind of get the idea. And then the next day, you can see a lot of debris, trash in that pond, but the skimmer's draining it down, over the course of the day. And then we get some additional rain come in, but then and it didn't drain down all that day, but you get the idea is that over 24 to 48 hours, that pond's going to drain down. And again, this pond, will state, we haven't adjusted the design based on the filter. We just still have that outlet structure releasing the water based on the previous design of holding that water for 24-hour minimum time. So why would you want to consider filtration instead of settling? So number one, if you do it with a pond, you've got a large containment volume to reduce the maintenance for frequency and treat larger drainage areas. There's also excellent potential to retrofit older basins that did not include water quality benefits if you can maintain the peak flow rate. So if you're on here with me today, you're probably not attending the IECA event in Charlotte. This is going on today and tomorrow. But if you were, or you happen to be there tomorrow, I'm actually doing a talk on how to retrofit basins with this. But the key is maintain that peak flow rate because most ponds, unlike our sample, don't have the additional volume available to be redesigned. And then filters and ponds can be relatively easy to access and maintain. You saw that one, in the video. It's pretty easy to pull it over to the side, or when the pond drains down, easy to get to it. Especially if you're comparing that to like underground vaults that require confined space entry. So you also have the benefit that your peak rate of discharge can be based on your filter treatment flow rate up to that first quantity storm event. So in most areas, that first quantity storm we're trying to maintain is a 2-year storm. So you can allow, as long as that filter can handle a flow rate up to that 2-year storm rate, then you can discharge your water quality volume at up to that rate. Now, it won't be quite that high because it won't be that high in the pond, but you get the idea on that. Here's the big factor is the filter is going to treat 100% of runoff from the storms up to the peak rate of the filter. So this is important because what happens now when we have a pond that's designed for that first flush, 1 inch, 1.5 inch rainfall, runoff event, and instead we get a 1/4 inch and it happens over 8 hours. It's basically straight in and straight out of the pond. And if all of our pond treatment is based on ponding to allow settlement, and you get no ponding, how much treatment do you get? Obviously, very little. You may get some from vegetation, a little bit of filtering, but you're not getting time for the sediment to settle out of the water. And then the other thing is, like we've done, is your filtration media can be customized to target specific pollutants of concern. So we've already incorporated media to target hydrocarbons and potentially help with metals. Future research is going to include nutrients, trying to see what we can do from a media standpoint for nitrogen and phosphorus and other nutrients or other pollutants. So if we now add the benefit of skimmers with filtration, why would you do that? We kind of talked about, hey, what could filters do? But now if you add a skimmer to that filter as well, one, your skimmer is now your flow control device. So you can size the skimmer to control that peak rate for the lower storm event, i.e. the 2-year storm. The skimmer is going to increase that filter efficiency by withdrawing from the surface where the water is cleaner. Again, if your filter was down here at the bottom, let's say we just put in a low flow orifice and a perforated pipe and we wrapped it with some sort of filter, that's going to get clogged up really quick, right? Or get covered up because it's where the sediment concentration is highest. By using it with a skimmer, we're not trying to treat that dirty water. We're trying to treat the less dirty water up top and let settlement also continue to do its job. And then again, the skimmer is pretty easy to access for maintenance. Now, there's not perfect. There are some challenges. So your number one is the filters are going to be prone to clog over time, and they're going to require some periodic cleaning or changing. So right now, we recommend a 2-year time frame to replace the filter. That's just based on how long we had it in the pond as a prototype. We know it lasts that long, so we're comfortable with that. The current one that's out there has been there now over a year, and it will keep it out there for probably 3 or 4 years, maybe 5, and kind of see when it's no longer functioning. Number two is the skimmer's got to be durable and last more than a few years to be suitable for permanent use. So you really don't want to use a PVC product for this. PVC is not going to hold up in the sunlight. Our product's an HDP product. There are other skimmers out there that have now come around that are looking to be more permanent use skimmers. So this idea is starting to catch on. Then the biggest challenge for us is there are no established standards for basis of design and permitting. So for any of our folks on here that are MS4 related, your manual probably doesn't tell you that I could use a filter in a pond and how that design should work. Now, a lot of manuals have MTD products in there, proprietary products, and how those will be done based on manufacturer recommendations, based on third-party testing to prove they work. And you can combine that with a pond, but sometimes when you combine that with a pond, you're no longer meeting the pond design because you're not holding that inch or inch and a half for 24 or 48 hours, whatever the local state requirement is. So real quick, we'll wrap up. with a quick example of modeling post-construction water quality volume-based, first flush versus filtration-based. Let's see why one would be better than the other. So our sample site here is 5 acres. Excuse me, I'm going to take 1 second before we get in there. I got one more question on there. How do these function for freezing climates? That's going to be a limitation, depending on how much freezing you get, this product may not be, the thing to use. If you have months of freezing, we may not do that. If you have limited freezing, you could always put in a valve with a perforated riser as an alternative to let it out during limited times. But we probably wouldn't recommend this necessarily if you're going to have, 3 or 4 months of frozen conditions. So go back to the sample site, 5 acres, got a curve number, let's call it wooded, pre-development 55, post-development, we're going to turn it into a little shopping center, curve number 92. So first thing we're going to do is do our pre-development flow rates. Now I've got all storms in here, but we're going to focus on the 2-year storm. And so we assume the time of concentration of 48 minutes, and we got a flow rate of just 0.72 CFS for our 2-year storm. And then you can see the 10, 25, and 100 on here. Next thing we're going to do is let's look at our water quality volume and our post-development flow rates. So we now assume that 5-acre site goes to commercial, time of concentration drops down to 10 minutes. And we need to calculate what that water quality storm event is. And this was done in South Carolina, so it's a 1 inch of runoff volume. Other states do vary. I believe it's 1.2 inches in Georgia. It's 1 inch in Tennessee, 1 or 1.5 in North Carolina. I think it's 1.5 in Indiana. So depending on where you are, that volume may vary. But in this case, I came up with a 1.73 inch 24-hour storm to generate 18,150 cubic feet. And if you run that through the model, you get a peak flow rate coming off the site of about 7.2 CFS. 2-year jumps up from 0.72 to all the way to 19.72. And then the 10-year, 25-year, and 100-year, they all have about a 10 times, almost a 10 times increase in there. So now, for the first flush side, most engineers have a spreadsheet that's kind of similar to this, where they calculate the orifice size to release that first flush volume. So in this case, our volume, again, 5 acres. So we got a contributing area of 5 acres, which is going to generate 18,150 cubic feet based on that 1 inch. We're going to release that over 24 hours. So we're going to come up, that's our flow rate. If this volume instantaneously enters the pond, which obviously doesn't happen, but if it did, that would be our volume. And then based on the head there, average head of 1.5 feet, come up with a 2.6 inch orifice. All right, so first thing is, like we said, this volume is not going to enter instantaneously. It's going to come in over time and go out over time. So it's a little bit flawed in design, but this is generally what is accepted by most MS4s. And so if we didn't run our model in hydroflow with this, I think I actually ran in HydroCAD, but got a 3 inch low flow orifice here. So I went from 2.6 to 3 inches just because I felt that was easier to be able to put in place. Our pond depth is 3 feet to create that water quality volume of 18,150 cubic feet. Then we have a 3 inch orifice above that to control our 2-year storm, an 8 inch orifice for our 10-year storm. And then we've got our topper riser for 25 and emergency spillway for 100. And so if we run the numbers here, our water quality storm is releasing that flow at 0.25 CFS. Again, we were trying to target 0.21, so I might have to reduce that from a 3 to 2.5. Peak elevation is only 12.5, and we're only using 10,700 cubic feet of volume, a lot less than that 18,100 cubic feet that's required. And so really we should be able to take that 3 inch orifice and lower it down, but the standards for most areas are you can't have any other orifices other than your low flow orifice below that water quality volume depth. And then our 2-year storms going out at about 0.81, which is slightly higher than our pre-development peak flow, but maybe a 1/10 of a CFS increase is allowable. So the option here to look at it with a skimmer and filter is let's pick a skimmer that's going to have a flow rate similar to the 2-year storm event. So in this case, that would be our 6 inch skimmer with a 6 inch orifice, has a flow rate of about 0.78. And so The filter here, we have these details available on our website as well. Again, have the two skirt system, and excuse me, both of them hang down about 36 inches in the water. One thing to point out is that the sizing of these is scaled based on the testing of our 4-inch skimmer. And so we have to maintain the area of the filter, and we maintain the length of the filter. So some of these get pretty large. And the reason we have an L1 and an L2 is we don't want this length to go over basically 16 feet, because we don't want, let's say, assume we have a 20-foot piece of pipe, which is really the longest you get a single pipe. If that comes up at a 45, you really now only have 10 feet between your skimmer and your riser. And so we limit this to 8 feet from the skimmer to the riser, skimmer to filter. So it doesn't touch the riser. This is the detail. You may remember in our previous detail, we showed the skimmer kind of going parallel to the dam. In this case, we've got it sticking more straight out. That's because some of these, again, filters get larger and we need to have room for them. But this has all your pond information again for that. And so if we look at the skimmer flow rate, we now got a 6-inch skimmer. It's controlling our water quality event and our 2-year storm. It's releasing that water quality volume at 0.7 CFS, which is 3 times higher than what it was with just the 3-inch outlet. And now we're only using 7,600 cubic feet of volume compared to that 18,150 cubic feet there. And the peak elevation in the pond has dropped to half a foot, for that water quality storm. And then our 2-year storm now down to 0.78 CFS, so slightly lower, slightly closer to pre-development. And so the other advantage here is because the skimmer is controlling the 2-year storm, the filter's now treating the 2-year storm and every storm event below that. And so if you compare these, and that's not a good chart, I'm going to switch to the next one. If you look at the difference in storage required for traditional versus skimmer, almost 30% for your water quality storm, 14% and 12%. So you've reduced your pond size in the process of using the filter-based design. So in summary here, if you just look at skimmers without the filter, they're less prone to clog than orifice located at the bottom of the pond. They're going to require a little less maintenance to keep the pond functioning properly. They're still going to need maintenance, not saying they're maintenance free, but they're going to require less maintenance. Skimmers can be a very effective way to retrofit basins to reduce maintenance, and you're going to provide enhanced water quality. So we've retrofitted a number of ponds without the filter, but just from a maintenance standpoint, so that they're easier to maintain, but maintain that low flow rate, maintain that 24-hour drawdown time of the water quality volume. And by releasing that water from the surface, you're going to get enhanced water quality. Again, we haven't tested it with just the skimmer itself, but with the filter, we have tested it, and we've confirmed we get 90% TSS removal, which is going to meet most standards. Most are 80%, some places 85%, but haven't seen anything over 85% yet. The skimmer is going to treat more of the annual rainfall, in those very small storm events, going to have to go through the filter to get discharged. And the larger events that are managed by the skimmer mean they're also managed by the filter. So you're now treating anywhere from the tiny events all the way up to maybe your 2-year storm. And then the other advantage is your filtration model reduces the pond size by 15 to 20% over traditional first flush. All right. So one last question for you is, now that you've heard about the advantages or benefits of potentially using a skimmer for permanent use, what's your thoughts? Do you still think no, maybe if it's the right project, or yes, it's a good idea? We always have at least one no. So I appreciate your thoughts on that. And, like we talked about, if it's freezing conditions, or if you're up in, certain parts of Ohio or Minnesota or maybe Indiana, that may not be the right thing to do. In the poll now, because we're about out of time, share that. So we had 66% said it may be for the right project, which I certainly agree. And 31% said, yes, it's a good idea. Again, you've got to caveat that for the right project. It's not a one size fits all for everywhere. So we got, almost 97% thinking, hey, maybe we've got a good idea now. So appreciate those thoughts. All right. And then I know we're at our time. So real quickly, we'll run through our stuff. Let's talk about our website. We are pretty proud of our website. We try to keep it up to date and one of the best in the industry. We have resources and training, like I mentioned to start. This webinar will be on the website in the next day or two. We also have a training series that's broken into 8 parts that breaks down different parts of the webinar. Also includes some things like I didn't talk about SEDCAD today. So those of you in South Carolina, if you need SEDCAD, it'll talk about that. This is our engineers pack where you can download the spec pack and all our details and information. Again, our product's made of HDPE. It's very UV resistant, no moving parts. It's got this debris guard around it. We say it'll continue to work in mild frozen conditions because it does take water in below the surface, but it's not going to work in a foot of ice. We talked about our orifice plate. This is a quick little video on it to show how it works. So again, it's just a sheet of EPDM rubber. Got this little metal nub in there. You rotate it to get to the right orifice size, and that little nub makes sure it's always centered over the thing. So every model of our skimmer has at least 3 flow rates. Most of them have 4 to 5, and all have been third-party tested to verify the flow rate. We've got our skimmer was redesigned 5 years ago. Originally, it would have a little top heavy, so we redesigned it to lower the center of gravity so it always floats and stays level. Our 6 and 8 inch models, they're pretty heavy. They weigh about 200 pounds a piece. So they actually, the floats come with handles to make it easier to be carried around. And just to point out, we do have 6 different models and we have 2 different 8 inch models. So we have our standard 8 inch uses a 6 inch pipe, and our 8 inch with our 8 inch pipe, we kind of refer to that as our 8 inch max. That flow rate is 1.8 CFS, which is nearly double what most other 8 inch skimmers can flow. So if you've got a really large site, so we're seeing a lot of solar farms, that kind of stuff now, big sites, big basins, we've seen basins with as many as 5 8 inch skimmers, and we're able to reduce that down to 2 of our 8 inch max. So pretty significant cost savings, as well as just making it easier to function on site. So that's it. Appreciate you hanging in with me. I know we just barely went over a couple of minutes. But if you do need a PDH certificate, please email us. Send that to info@rymarwaterworks.com, and that will go to our team, and we will get that back out to you. Please go to our website and download our spec pack, and hopefully you'll consider specifying the Marley float on your next project. If anybody has any other questions, I'm happy to stay on a minute and answer them.
Sir, would that be possible to have a PDF version of your presentation?
Would be happy to do that. Just shoot me an email, and so I've got your correct email address, and I'll be glad to send it to you.
Okay, info@marleyfloors.com.
You can send it to that info@rymarwaterworks.com.
Okay, the email that I received the other day
Yeah,
from.
just email that, and myself or Richard or
back.
Kelly will get it to you.
Okay. The question is about the water quality. That water quality which is coming out of the skimmer and through the control structure is going back into the creek or in the river, correct?
Correct. Yeah, it's discharged to wherever it's going off-site, typically into some sort of a channel.
And ultimately that it becomes the source of the domestic water.
I mean, it just becomes part of the normal stormwater runoff. Yeah. So it may, it is going to wherever it flows downstream. So yeah, it would be eventually just domestic water. We're definitely not saying it's drinking water, coming out of the pond.
Not drinking water from the skimmer or from the detention pond, but it eventually goes to the treatment plant.
Right. Ultimately, yeah, it would go to some sort of, well, I mean, in most cases, it's going to a river or stream and not to a treatment plant.
Yeah, but they pump it out from the ground anyway.
Right.
Okay, thank you.
Okay. Any other questions? Great. I appreciate you joining us today. Hope you have a great day, great week. And thanks for considering the Marley float.
Thanks, sir. Bye.